Welcome to SQL 101, the journey towards PostgreSQL. Let's go ahead and get started here. A little bit about our series. Today, we are talking about tips and lessons that I have picked up as I am learning Postgres. We're going to talk about that. We're going to go into some details. Next month, August 22nd, Ryan will be back in the chair, and he's going to be talking about the top 10 extensions that you need to know about. Extensions are really important. I'm not going to spend a lot of time on those today, but I will bring up a couple. Ryan going to dig into it, so don't worry, you're going to get all you need out of Ryan next month. Today, we're just going to talk about learning PostgreSQL as a SQL Server DBA. There's some interesting challenges, some actually interesting easy bits too. It's nice to know. But some housekeeping. The session is being recorded and it will be shared after the fact, so you can watch it again later if you need to. Also, there is a Q&A box right there on your screen. Please go ahead and type right in there and use it. I might not answer your question immediately, but I will try to get to your questions as we go. So type them in there, I will see them, and then we can keep going. So please don't hesitate, interrupt me, ask questions as we go along. So I really appreciate it. Other than that, I think that's all of our housekeeping items. Let's go ahead and get going. My name is Grant Fritchey. I work for Redgate Software. My experience, I hate About Me slides. I'm just not a big fan of them. For me, not for other people. Not being critical when other people use them. I don't like using. I hate talking about myself. No one cares. But the importance today is that I am a Microsoft Data Platform MVP. I'm also an AWS community builder, again, on the data platform for AWS. And most of my expertise over the years has been within SQL Server. I've got some experience definitely with Sybase. I've got some experience with Oracle. I've been in some of the other databases, MySQL, Mongo, but most of my experience really is SQL Server. But for the last 2 years, I have been learning Postgres, and I want to talk about why I'm learning it and the challenges I've had in picking it up, and some of the things that maybe can get you over the hump if you're trying to learn it as well. So in this case, I did want to talk a little bit about why, I'm here and why I'm the one talking. So now you know. If you've got questions after today, this is my contact information. Please go ahead and use it. This is my Twitter handle. This is my email address, my direct email, and this is my blog. So you can always get in touch with me with one of these 3 ways. I like to help out. So if you've got a question, please do use it. All right. So let's start off. We are talking Postgres 101, right? This is a base level thing. So what is PostgreSQL? I mean, why are we here? Well, it is an object relational, and that's an important thing to differentiate. It's object relational, open source data management system, and it is 35 years old. This is not new technology. This is not shiny. It's funny. It seems to get treated as shiny a lot, and I'm not saying anything bad about it when I say it's not shiny thing. It's not brand spanking new. It's definitely not the newest kid on the block. There are more recent database management systems than what we're looking at here with PostgreSQL. But the fact is that because it's 35 years old, there's been a lot of development on it, and it's extremely stable. There's a lot of cool functionality. And that combined with the fact that it is relational, but has that whole object-oriented aspect to it, make this pretty exciting technology. So this is why a lot of people are into it. But let's drill down a little bit more. Now, why am I pursuing Postgres? Why specifically am I sitting here talking to you about PostgreSQL? And there's a few reasons. One, I am a firm believer in lifelong learning. I refuse to sit on my laurels, to sit on my knowledge, and oh, cool, I don't have to learn anything else. Technology is constantly shifting. There are constantly new technologies. People figure out better ways to get things done, and we can listen to them, learn from them, and expand our stuff all the time. So Why am I chasing Postgres? Because it's part of my learning aspects. And it's very much, I see it as a natural extension of what I already know to expand into secondary set of data that a lot of people need help with, a lot of people are using for a lot of good reasons. And we're going to get into some of that. The other reason why Postgres is because it is a relational data store. My knowledge and skill set and the skills I'm going to bring to already existing structure and already existing system um, are based on relational work. I mean, that's what I've done for a very long time. I am 60 years old. I've been in this industry for well over 30 years. So more than half my life doing this kind of work. And almost every bit of it has been on relational data store. So I wanted to stay inside of the relational data store when I started learning new stuff. And so that's another reason why I picked Postgres. Now, further, I did want to ensure that I've got the right kinds of multi-platform knowledge. And Postgres gives us a whole bunch of reasons for that. One, it's more native on Linux, so work I could do in the Linux area, and then working with Postgres, it helps me expand that knowledge set. Also, it is, well, we'll get that in a second, but it's a very fast growing database. And so there's a lot of reasons to get in there and learn from it. Also, what we're finding is through surveys, through sales, through support calls, man, all of you out there are trying to juggle more than one data platform. Multi-platform now. So it is to have multi-platform knowledge to be a useful contributor to our industry. And so that's one of the other reasons. Finally, and I've said it several times, the technology inside of Postgres is fascinating. They have taken different approaches than other database platforms. There are different mechanisms than other database platforms. You're going to see a lot of additional functionality in there. Now, some of it's not as good. I'm going to say that up front. I'm not a fanboy where I have to say nice things all the time. Some of it's better, right? They've got all kinds of new stuff going on in there, and some of it's just new and different, and that's good because it's an extra tool in your toolbox. Some of it's better than the tools you have now, and depending on the platform that you're on, MySQL, Oracle, Postgres has advances over those, Server even. And then some of it's just different, but all of it's fascinating. And so it's a lot of fun to learn. So I've really been enjoying it. And so this is why I've been digging in to Postgres. But that's not all. Now, this is from the DB Engine's ranking. There's a link right there on the screen. You can follow if you want to, or when these slides are made available, I assume they will be. The link will be there too. But you can look this up. This is just as of a few days ago. This is the growth or shrinkage of base usage over time. And you can see that orange graph right there in the center and the steady growth that it has experienced over the last, 10 years. Whereas other data platforms, some have been growing. MongoDB was growing like crazy, although it seems like it may have plateaued. Redis, kind of plateaued. DB2 is shrinking. But even the big three, MySQL, Oracle, SQL Server, they're shrinking in terms of market share. Not radically, but there's a lot going on. Okay. And there was I did glitch out there for a second. Apparently, I'm back online. Um, we're just going to keep going. I don't think I missed anything really important. It's basically just talking about why I'm doing Postgres. So, cool. Anyway, sorry about that. Do apologize. Let's keep going. So the industry rankings are another driver. Postgres is clearly growing like crazy. It is very popular and getting more so. So it was another good reason to choose it to add to my skill set. So that's why I picked it. Finally, because I left this out and I hadn't mentioned it on purpose, when I went to go and look for a new Postgres, or sorry, new Postgres, a new data platform to start learning, one of the things, I'll just say it, I'm spoiled. I have been extremely spoiled by being brought up within the SQL Server community. I love the SQL Server community. I can't say enough good things about the SQL Server community. SQL family is a real thing, and it's just fantastic, and it's made a huge difference in my technical life and in my personal life. And so when I went to go find a new database platform, I went looking for a new community. And the good news here is PostgreSQL has got a fantastic community. There is a lot of support out there, and it's kind. It's kind support. People really do care and want to help you. This is another reason why I chose Postgres as the technology I wanted to pick up. Not throwing rocks at the other technologies, but frankly, the communities around them were not as kind, as open, as encouraging as what you get from the Postgres SQL community. It is a lot like the SQL Server community. And so it felt very comfortable, and it was a great reason to go. All right, enough of the feel goods. Let's start talking about tech, right? But before we do, I would like to make a big caveat here right now. I do not consider myself a PostgreSQL expert. And so if that means everybody wants to run away, now's a good time to do it. I am not an expert. I don't know vast quantities of this technology. I am learning this technology. I am actively picking it up as I go along. And I want to be very clear about that up front. So as we go through the rest of the session, it is very much an introductory 101 level session, but I still might get a couple of things wrong. That's okay. Type in a question, let me know, and or type in a comment, let me know, and I will then address those as we go along. But I might get some small things wrong. Overall, I think I'll be okay. But I do want to caution you that I am not an expert. That said, my son reminded me, because I've always seen him, is an expert, a real expert, is somebody who's page ahead of you in the book. So if you're just getting started on Postgres, I've been in it for about 2 years. I might be a page ahead of you in the book, in which case, kind of I'm an expert. That said, I do want to put that caveat up front. So everybody's okay. Let's keep going. Where to start, right? So, okay, so you've decided, hey, I'm going to get Postgres. I want to start learning. Well, same thing I did. I said, okay, I want to get Postgres. I want to start learning. Well, what do? Well, you've got choices. Now, I'm going to focus on the two choices that I picked. I did all three of these. I went after the local host. I downloaded and installed Postgres. I installed it on Linux so I could see what it was like there. I installed it on Windows so I could see what it was like there. Cool, great, awesome. There was a new upgrade to Postgres. I didn't want to upgrade because I don't like upgrading. It becomes a pain in the bottom. So what did I do? I went to a container because I've found containers to be a great way to pick up new technologies, to get new information and get new stuff. When do you really care about the placement of disks in every instance that you're messing with? Probably not. A lot of times, all that really matters is that you get a functional database management software. Well, hey, containers, Docker Run is a great way to go. Now, let me just show you what demos we're going to be running today are, in fact, running on a Docker image here. I've got the Hamshack server, which is running Postgres. It's up, it's running, it's been going for the last day because I was getting ready for the presentations today. And so I've got my Postgres SQL server running. And that's how I'm doing it, is through a container. Now, the other mechanism I use is cloud. I use AWS Developer, definitely, or sorry, AWS RDS with Postgres. I've also used AWS Aurora with Postgres, although I have found the Aurora functionally to be pretty much, at least at my level of Postgres knowledge, it's exact. But I have found some of the behaviors around it be just a little weird. So I've kind of stuck to RDS just to avoid messing with my brain. That Aurora was slightly different than RDS. So RDS seems to be much more generic, and so I went after the more generic one for the learning that I'm doing. I'm not saying one's superior to the other. Probably Aurora is probably a better mechanism, um, but the behavioral differences were enough that I stuck to RDS. And the other one I'm using is Azure and the PostgreSQL on Azure SQL Database. Fantastic stuff. And the main reason I'm leaning on containers is because they're easy for upgrades. It's quick, it's fast. I don't have to do installs. I just get the newest version and I'm done. Great. And the reason I lean on the cloud services so much is because they're taking away a lot of the stuff I don't want to have to mess with yet. I don't want to have to maintain the OS underneath my Postgres. I don't want to have to maintain what version of Postgres I'm on and do patching and all that other stuff. Right now, what I'm interested in is having a database and running it. And the cloud services get me there. Fast, fast, fast. The containers help too, especially because it gives me a local thing to run. I don't have to be cloud connected. But my main work that I've been mainly through the cloud services. And so that's why I'm starting there, and that's why I recommend you start there. However, if you are going to be hardcore administration of on-premises, big iron or in virtual machines, PostgreSQL, you are going to need to learn how to run it from the local host, configure all the rest of that stuff. So initially, can you get going with containers and cloud services? Absolutely, I recommend it. But ultimately, are you going to have to expand into that local host? Well, it depends on your situation, but yeah, some of you will. And so know that it's there, know that you can use it, but don't feel you have to start there. You can actually start where I started. Cloud and containers get you going. Okay, and remember, as we go along, ask questions. Okay, so how do we start? Well, the good news is the start's the easy part, because the syntax, at least, especially if you're already experienced in, say, MySQL or Oracle SQL Server, especially SQL Server, and to a lesser extent Oracle, although I've heard people argue the other way that Oracle's more of a match than SQL Server. Either way, the basics, a database with a database name, done, right? It's ANSI SQL for the most part, and extremely focused on being ANSI compliant. Now, are they in all cases ANSI compliant? They're not. In fact, they're not always ANSI compliant, and intentionally so, because they create new functionality that's not in the ANSI standard, and therefore they have to have non-ANSI commands. And same as Oracle, same as SQL Server, same as MySQL, and I'll grant you, there's probably not as much of a focus on MySQL, SQL Server, and the others to being ANSI compliant as much as possible. I'm sure, and I know that they have deviated more than Postgres has, but Postgres has also deviated. So don't get hung on the hype of, once you know ANSI, you're done. It's like, well, there's more to it than that. But the good news is, once you know the basics of ANSI, you're done, because create table, create database, create schema are all in fact the same. Let's just take a quick look at one second. This is the create commands that I've been using for my, oh, by the way, I've been writing a, there it is. I've been writing a series of articles as I learned Postgres. And so a lot of this presentation is based on that series of articles. And so you can go track those down after the fact. I'll link here a little bit later. And this is all based on that. And so we've got really simple commands right up front. I mean, drop database if exists, create database. I mean, and that's it. That's all you need. You can create a database, you get going. Create a schema. Okay, cool. Now, granted, here's your first little bit of difference, because grant usage on schema, that's not the same as SQL Server, but it's fairly straightforward. Create table if not exists. easy, understandable, very straightforward. Again, integers, a constraint with a name primary key. Okay, generated, um, necessarily a thing, and all capitalized. Code formatting in this tool isn't always the greatest. We'll talk tools in just a second. That should be capitalized. But anyway, the basic stuff, varchar 100, integer, they're all the things that you would expect to see. So it's the very start of it. It's very simple to get going. So that's exciting because you can get your feet wet without feeling like you have to spend days learning. You can just start to poke at it and get some stuff done. You're going to hit issues occasionally, but overall, it's going to work really well for you. All right. Any questions so far? None that I see. Cool. All right. Let's talk tools first. Now, the main tools I've been using. Oh, does Postgres have the equivalent of an instance, or is the database kind of equivalent? So Postgres has a server. Here, let's go back to here for 1 second. I'm going to look at some other tools in a minute too, but Postgres has a server. So my server here is Hamshack Radio, and then Hamshack Radio has multiple databases inside of it. So there is server. Now that server is an instance. There's not a way to do multiple instances per se within a given install, except that you can. It's just, again, the trick is it's changing ports so that it's listening multiple ports, and then it can run the same way. So effectively, yeah, it has some idea as an instance. Great question. Thank you for asking. All right. So the tools we're looking at, well, obviously pSQL, that's your command line tool to get going. Then there is a GUI, pgadmin, again, provided through Postgres. That is part of the Postgres stuff. But then there's third-party things. And I'm using a lot more third-party stuff. And we'll take a look at why. The main one I've been using the most is dbeaver. You already just saw it there. But I'm also using Azure Data Studio and Visual Studio Code for a lot of work that I'm doing. So let's just take a look at, let's take a look first at pgadmin. Now, so pgadmin probably looks quite a lot like what we were just looking at in dbeaver. We've got, the servers that I've got. I'm connected up to my local host, which you saw earlier was the container. That's got 4 databases inside of it. One of those databases is Hamshack Radio. That's got schemas. One of the schemas is radio. And then inside there are tables, and the tables are tables. I mean, there's, I can expand one of these out, and it has columns. And, it's just all the stuff that you're used to seeing if you're used to this kind of graphical explorer. So this works. I'm not crazy about it. I found it a little hard to use. The SQL wasn't as responsive. There wasn't as quick a mechanisms. And so I generally shy away from using this. Mainly, I spend my time in dbeaver. Oops. There we go. So this is dbeaver. I'm a lot more comfortable with it. It hooks into source control better. I've just overall found it to be a better tool. And by the way, it also allows you to connect up to MySQL as well as Postgres. So there's some nice stuff going on there. Now, the other tool I've been using a lot of is Azure Data Studio. Now, Azure Data Studio, you'll notice, has got a Postgres connection. It's just a plugin. You download it, and you're off and running. But then again, we're hooked up to the Postgres local host, to the Hamshack radio, and then the tables are laid out. And if we take a look at the antenna, you can see the columns and everything. Pretty much what you saw before. I mean, I do like the fact that it includes the data types and the descriptor. Let's make it so you can see that. There you go. And so there's a lot of information in there, and it makes it a little easier to use and makes it simpler to work with. The T-SQL editor is much more responsive. It's very fast. Code completion's not there, but it's pretty cool stuff. So, I mean, it's very handy. It's why I like using it. Now, the other tool that I'm using, and I'm not going to spend a lot of time here just at the moment because I want to come back to here for another purpose, is Visual Studio Code. Visual Studio Code, again, it's Azure Data Studio is a fork of it. And so a lot of the behaviors that you get in one, you'll get in the other. And frankly, it's just a snappy, easy way to get coding done. And so I use this for a lot of my PowerShell and Bash commands as I'm working inside of Postgres. Cool. That's all of that. Any questions on the tools that we're talking about today? Okay on time? Excellent. Well, let's get going. Now, weirdly enough, the first thing I did when I was working with Postgres is I immediately went to backups and restores. Now, you might ask why. I mean, because a lot of people are like, well, no, you got to create a database, you got to create tables, you got to put data in there, you got to have store procedures, views, partitioning, replication, all of this before you ever get anywhere near backups. Yeah. All right. So I've got 30 plus years in the industry, and 30 plus years in the industry has taught me to be paranoid, to be a paranoid control freak. So one of the very first things I learned, was how to do a backup and how to do a restore. And the reason being is that you need to start with a restore strategy, right? It's backup strategies, that's not real. Restore strategy. How am I going to restore this thing? Because that defines your backup strategy. How you're going to do restores tells you how to do backups. That simple. So figure out how you're going to do restores, and then figure out how to get backups in place to make that restore happen. That's it. It's nice and simple. But I did start there because it was really important to me that as a DBA, I know how to do a backup and I know how to do a restore. And it's vital, right? It's vital because guaranteed at some point in your career, someone's going to drop a table that didn't mean to. Someone's going to delete a row that didn't mean to. Someone's going to drop the entire database that didn't mean to. You're going to have access from people that shouldn't have access, or people who should have access but are being accidentally destructive. You're going to need to restore stuff. Guaranteed, you're going to need to restore stuff. Start there. Know how to do that day one. Now, a question has come in. I have a new position as a DBA. Focus is going to be on Postgres and Postgres only. Well, it's cool that it's only one technology. That narrows things down, makes it easy. Postgres is vast. No kidding, it is. It's huge. And I find it hard. What topic should I learn first? Where should I main focus be as a DBA to understand? Guess what? Backups. Backups, backups, backups. You can do backups and you can do restores. And that's a great place to start. It's simple, it's straightforward, and I would start there. The reason being is you probably already got it running in-house. They've probably already got it up. But you can get in there and make sure that you've got backups, and further make sure you can do restores. Practice your restores. That's the very first task. Practice or restore. Now, the second question that comes up with backups, and this one's really important. Are you using the native mechanisms, or are you looking at one of the extensions? Or are you looking at a cloud service? Now, the cloud service, if you're on the cloud, great. Backups are already there. Now, you may want to enhance them. You may want to look at what the SLA is for whichever service you're using, and you may want to add to that. But backups are being done by AWS. They're being done by Google Cloud Platform. They're being done by Azure. So 100%, that's cool. That's already there. Then the question is native or extensions? And frankly, there's a PG Backstop. It's an extension. I'm not going to step on Ryan's toes because he may have a different recommendation, but I'm telling you up front, that's a pretty cool extension. It's got a great developer running it. I've met the guy. I got to talk to him. I learned a whole bunch of stuff from him, and I'm pretty excited about it. But if you go and look at my article on backups, one of the first ones written in the series, I did it all with native tools, mainly because I wanted to know what native tools were available. I wanted to learn at first. Just because it provides a foundation for my knowledge and where I started. Now, if we take a look at it, I've got some questions I know. I'll get to them in a second. If we take a look at what I was doing with this, um, it's PG dump, right? PG dump is the native mechanism, and that's it spits out stuff. And there are some issues with it. It isn't easy to ignore from it. It's hard to do time recovery using some of the Nate tools. There's some real challenges here, but they work. You can get the job done, and so it's my important thing is to start there. So that's why. All right, now I can close this, and we're back to the slides. Now let me go back to the questions. One question said, "Did I mean code compilations not there in Azure Studio?" Sorry, I didn't misspeak. You may have misunderstood me, or I may have talked fast. Code completion, meaning type ahead, is not there in Azure Data Studio for Postgres. That's what I meant. Code completion, not code compilation. Sorry about that. And then someone says, I mainly use PG admin because it has a graphical explain plan. And do any other tools offer that functionality? Hey, guess what? There is a third-party tool out there that has it, but that's all I've seen so far. So PG admin may be the tool that you'll stick with for that kind of explain plans. I have not yet dug into explain plans. And anyone who actually knows me or my reputation inside of SQL Server, execution plans are my thing. I love execution plans, but I haven't dug into them yet in the explain plans in Postgres. So I'm just going to plead gross ignorance and keep going because that's safer than saying something extremely stupid, which I would do if you gave me the chance. All right. So backups are done. Cool. Data types. All right. So my first thing was I was told there were 20 categories of data types. And I just about lost my mind because I was like, okay, well, how many data types does that mean we have? It means that there's 3 or 4 per category. My God, there's a lot of data types. All right, here's the good news. Some of the categories have one data type. So it's kind of hard to call it a category when there's only one thing in the category, but fine. However, there are a lot of different data types, and it's really cool. The similarities are more common than the differences. A varchar is a variable character, a char is a fixed length character. An integer is a whole round number. Floats are, it if anybody's shocked by any of the things, the words that I'm saying, you need to hit the fundamentals a bit more because these are fundamental data types inside of databases, and they're largely the same, and the behaviors are largely the same. So it's the similarities are shocking, just the level of similarities. And I'm sure that largely ties back to everyone being at least somewhat compliant with the ANSI standard. And so having that standard available makes a big difference in learning as you go cross-platform. Now, some of the really interesting differences are, the way it does intervals. Now, intervals are basically kind of identity columns, but not exactly. So, I mean, it's something that you can look at for those sorts of things. It's kind of like having a sequence. The enum data types are really cool because it's an enum. It's an enumerated operator that you can set up within a data type as such. Arrays as data types and arrays of arrays of arrays of arrays of arrays as a data type is possible within Postgres because of the object-oriented nature of the build that it has originally. And then the other one that was really exciting to me was the range data type, the idea that you could set up these ranges with the knowledge that it's always going to be within this sort of thing. Made a real big difference in the way I started thinking about some of the data. Now let's just take a quick look at some of the data types available. Give me a second here. Data types. There we go. Now, is that the right one? That looks wrong. I use more than just bool data types. Where did that go? Oops. Huh. That's not the right file. Well, anyway, you can see what's going on there. insert statements are pretty much the way you would expect. The varchar. Create type microphone as waterproof speaker and earpiece. 3 bools, and then ta-da, create it as a microphone, and then I get to insert it that way. That's kind of cool, right? I mean, you can see how it's working here. There are the bools, and it works. It just works. So it's arrays and enums, and it lets you do these things directly. It's really cool. I've been very impressed with what you could do with data types. And there's a whole lot more that I haven't dug into nonstop. All right, index types, because indexing would be the next big thing you're going to focus on. All right, first up, there's a keyword, using. You want to learn that keyword. Do you have to use it? No, you don't. Not in all instances, but in some instances you have to, in other instances you don't. That's one of those, it's kind of like the semicolon as the statement terminator. My recommendation is put it everywhere. Some places need it, some places don't. But if you put it everywhere, you don't have to think about it. That's my recommendation. Same thing with using. I would put using on all of my index creations, and we'll get to index creations in a second, but I would put it in there. Next up, name your indexes. Postgres will name them for you. Postgres is helpful, which means it will let you create the same index 20 times because it's just going to give it a new name every time. Now, is there any reason why you would create the same index 20 times? Is there a functional purpose to that? No. And somebody's going to go, whoa, yeah, but what if you create a filtered index? Well, that's a different index because you can create a filtered index on the same column. Cool. So and we can create a third filtered index or a fourth or fifth. We can create filtered indexes, but those are different indexes because they have different filters. But you can create the exact same identical index 20 times if you want to. Just keep running it, and it will generate a new name every time. And you will then have 20 indexes on one column. And when you do an insert, it's get inserted to all 20 indexes, and everything slows down, and you're wondering why performance sucks. Well, there you go. There's one reason. So, I mean, get your index names as part of the standard right from the start. Don't rely upon the fact it's helping you, because then it will hurt you. So that's my first thing on indexes. Next thing, there are 3 amazing mechanisms within indexing you need to know. First up is the generalized search tree, or the GIST. How to describe it? It's an index for things that shouldn't be indexed. It's not entirely true. It's basically a programmatic extension. Think of it like if you're a SQL Server person and you know there's Entity Framework plugins, this is a way to create indexes out of Entity Framework. Now it's more sophisticated than that. There's actually a bunch more going on than that, but the idea is there. It's a way to index things that you wouldn't have been able to index otherwise, because you can build custom behaviors. And that's what the generalized search tree is going to allow you to create. Now, the next one is a generalized inverted index. Now, the inverted index, let's get this one right. It's all about the arrays. Now, when you create array data types, they're going to need to be able to, you're going to have to be able to search through the array, especially when it's an array of arrays and an array of arrays. You're going to want to be able to find stuff within that data type, right? There's going to be where clauses where it says where this is in this data type. The generalized inverted index is what's going to help you with your arrays. So that's another one to focus on. And then finally, and by the way, I'm calling out these 3 distinct indexes. There's several other new types of indexes inside of Postgres. These are not the only ones you're going to see, but I'm calling these out because they are exciting and very interesting in terms of what you can do. Block range indexes is a way to do range indexes. Think a date range or a numeric range, but that you know the beginning and you know the end, but you want to be able to control within the range the order and the behaviors in a way that's completely different from a B-tree index. Cool. That's what the block range index is going to allow you to do. So there's some really neat stuff in there as well. So these are the things I would kind of focus on. Sure, B-tree indexes are a thing, man. It's part of the process. But here, let's take a look at the code real quick. We're not going to run a whole lot in here. index types. All right, so create index. There's a name on, but you'll notice what I'm not doing. I didn't use, oh no, I did. I didn't use using. This is where I'm using. Create index, give it a name, on, table name, using B tree. Now up here, what I was able to do is I was able to rely upon defaults. I don't trust defaults anymore. I'm too old for it. Now I want to type everything so I know exactly what's happening. So this is how you do it, using. Now you'll see if we scroll down here, the hash index, same idea. Create the index, give it a name, on, using, hash, and then the columns that you're going to be hashing the index on. Gist, notice, create index, index name. Brin, create index, index name, on, using, Brin. So this is the mechanisms that we are going to follow. And you'll see that they're pretty standard across the whole board. All the behavior is pretty much what you would expect. Once you learn how to create a B tree, you've also learned how to create a hash. You've also learned how to create a gist. So you'll be able to get all these things going. All right, cool. All right, no questions on that one. Awesome. All right, constraints. Postgres has constraints, and they are almost exactly the same as an constraint you would see anywhere else. You know, null, not null, behave sort of the same way. We're going to talk a little bit about null. Exclusion constraints are interesting too. We're going to talk a little bit about those. But the basic idea here is that the constraints are pretty much what you would expect. Primary key, everything has to be one way. Unique, everything has to be unique except null, which we're going to talk about in a second. Foreign keys are going to be the same. Calculated constraints, you can do those the same way. You know, have values all in here must be greater than 0, right? It's constraints are more or less exactly what you expect, except for the way null behaves and except for the way exclusions behave. Now, null. The concept of null, again, SQL Server, I'm using SQL Server as my baseline, but the concept of null is unknown and unknowable. It is something that we just don't have a value for. And null does not equal null because we don't know what this is and we don't know what this is. Unknown does not equal unknown because the two unknowns be very different, right? We don't know, so they don't match. Postgres treats it the same way. Nulls don't match nulls, which is cool. But by default, Postgres does a little bit different because what it does is it says, hey, since nulls don't match nulls, when you have a unique column, you can have more than one null because they don't match. Because they don't match, you can have 20 nulls, 50 nulls, 100 nulls. It doesn't matter. A million nulls. Doesn't matter. They're not matching, which my SQL Server brain freaks out and says, no, you get one null and then everything after that is a problem. Okay, well, let's take a look at this code real quick because you can get around that. Let's see. Indexing, where's constraints? Constraints. There we go. Sorry about that. All right. Unique nulls not distinct. Okay, so we can pass in additional information. Unique null's not distinct, unique null's distinct. You can control the way the null behaves. So the default is going to be multiple nulls are okay because nulls don't match nulls. Logically, it makes sense. My history with a different behavior, it makes me crazy. But to understand the logic is there. So it makes sense. All right, we're okay on time. And the other thing I wanted to talk about was the exclude. Now, exclusion constraint, there we go. The whole thing about exclusion constraints are they have to be unique across multiple columns. Now, if you do an equals, it's the same thing as having a unique constraint. But if you do greater than, less than, not equal to, or mix in other different things other than equals for these, you will then see all of that stuff available. I mean, sorry, see all that stuff available. I was looking at the question. Give me 1 second. You will then see that what the exclusion constraint does is it ensures that the combination of columns is unique in the combination, which is very different than a unique index. So it's kind of cool. So it's definitely worth looking at. There's some. I haven't done the performance testing with it, but it's one of those things that's good to know about. We got about 15 minutes left. Oh, can you share the scripts? The scripts are already all shared. If you go to ScaryDBA on GitHub, they're all available there under Learn Postgres with Grant. It's a full repo. Every one of these scripts and a bunch more are there and available to you. Okay, cool. Schema. All right. Here's the good news. Schema is the same. I mean, there's some minor differences. The search path. We'll talk real quick about the search path. But schemas are schemas. They are organizational structure and a security structure. Who owns what set of tables? I've defined this as a schema. It's over here. On the search front, can it store search XML and JSON like SQL Server does? Oh, yeah. Well, the gist indexes do a better job than SQL Server on terms of XML, and way better than SQL Server in terms of JSON. It actually indexes the stuff as JSON, and you can do searches against it and get some massive performance enhancements. Like I said, some stuff in this is better than SQL Server, just flat out. And JSON indexing is one of the big ones. So yeah, great question, and happy I could answer it. All right. The only real tricks here are there is a thing cascade in a schema. So if you want to drop a schema, you can cascade and drop everything inside of it. That makes it easy. Don't do that in production. Well, or do it if you want to, but make sure you get your backups ready. And then the other thing is search path. Let me just switch over to the code because I've got just over 10 minutes left. I want to make sure we get through everything. We switch over to the code and talk about search path real quick. Schema. So the search path is, where is it? There we go. Already had the query up too. And so you can see the results here. You can control which schemas are searchable by given logins. Now I'm not going into the detail here. This is 101, so we're very introductory. But schemas can be reordered and it will look in a particular order. Like right now it's looking public user, but I could put user in front. I could take public out and have it not ever look at public for my login. There's a lot of stuff I can do with search path. So I mean, it lets me have more direct control over what I can actually see in the database, which is cool because it's not just exclude things; it's kind of hide them, which is even better than excluding them. So I'm very excited about this. It's kind of cool. It's one of those that like people ask for all the time in SQL Server. Can I make it so they can't even see that stuff exists? And the short answer is like, nah, if they get into the database, they can see that the thing is there, even though they can't access it. Well, with this, they can't even see it's there. That's kind of cool. All right. Manipulating data. Insert, update, delete. Guess what? Insert, update, delete. Insert, define a set of columns, give it some values, comma separated, throw in some more values. Awesome. Off you go. Everything works. What you can do, though, is you can override system values. That gives you the ability to get rid of defaults and override the behavior. So it's an added thing that you can put onto any given column. Another fun one is on conflict. Do an insert statement and then say on conflict, do an update. It's basically a way to cheat merge because you can say, well, insert unless you can't insert, in which case just do an update for the same key values that caused the conflict. So on conflict, you can do that. You can also say on conflict, do nothing. If you hit an error, stop. No big deal. That's pretty cool too. It's another great way to get through. And then finally, there's the only command. Now, why is only a thing I'm calling out? And that's because data structures in Postgres can be inherited. Again, remember, this is object relational. It's primarily a relational database platform, everyone. It really is. but it's got objects in it, and they really do behave like objects, which means that you can inherit behaviors. And so if you want to, you can say only insert into the child table or only insert into the master table, or sorry, the main table that's been inherited. Um, you've got control over those things. So yay, we've got control. So it's a great way to get things done. All right, we've got 10 minutes left. Next. All right, so that's all the stuff I've been picking up. This is all the stuff I've been learning, and I kind of wanted to walk you guys up to some of the high points. But let's talk about the pain that I've had along the way, because this all hasn't been great sunshine and roses. I've had issues. And the first issue that I have is, and this is a big one, a lot of people hit this, that the people running, again, I admire the people running Postgres because it is open source. These people do this as volunteers. So, I mean, it is open source first, open source last, and it only third parties that are bringing in paid versions. PostgreSQL is open source, license free. Yeehaw. The documentation versions are going to get you. You do a search on the web, how to do a backup, and you're going to get in there, and there's going to be this great set of documentation showing you how to walk through it, and it's going to be on the Postgres website, so you're not going to be worried about that. Postgres.org, excellent. And you're not going to notice that you're looking at version 11 and version 15 is what you're running. Oops. So the documentation versions are really important. Learn to look for that. When you're looking at search results from the internet, and it's regardless of the search engine, I've used multiple search engines and had the same problem on every one. Keep an eye out for that documentation version, because you will start doing stupid stuff because you're doing things that are old, out of date, wrong. You'd be standing there, or at least I was standing there. Why isn't this working? I'm following the example code exactly. Well, yeah, because it was 4 versions old and it doesn't work like that anymore. Oh, okay. Next up, the documentation is thorough to a fairly well. I can't say enough good things about the documentation. But let me be really clear here. I went to film school. I don't have an IT degree. I am not an expert in information services. I don't know everything there is to know about tuples and all the rest of that stuff. And relational math is not something I've got in my repertoire. The documentation is very academic and science focused. It is not, frequently not, focused on, hi, I'm just Grant the Schmo. Can you please help me do the thing I need to do? I'm glad that you've got 75 pages of explaining to me why it does the things it does and how it does the things it does. I just want to know what command I have to issue to make it do those things. Please, please, please dumb it down for me, make it more simplistic. You're going to hit some issues if you're my level of intelligence. You're going to hit issues with the level of science in some of the documentation. It just is. And again, I'm not trying to throw rocks at it because it's amazing, right? I mean, we go through the top extensions. There's lots and lots and lots of extensions, and they could look very attractive. Oh, looks like I might be cutting out again. The extensions can be very attractive. You may hit issues with them. So be cautious in their use, be cautious in which ones you use. There are a million of them in there, but I would go slow on their use and be very, very careful. So far, I'm like 12, 13 articles into learning Postgres, and I've used one extension so far. For a good reason. It has to do with gen indexes. Or is it gist? I forget. There's a plugin that makes the functionality of gist indexes better, but like not better as in like, oh, slightly better as in night and day, functionally way better. So I would definitely look at that plugin. But anyway, also the other thing you're going to run into is that and the poor person just getting started, there's not a lot of guidance on core behaviors and best practices. Again, going back to the academic thing, 35-year-old, academic focused, science focused. There's a lot of people who know a lot of things about the very, very low level of exactly how Postgres works. They're not as interested in teaching us about the high level. Okay, great, that's awesome. What happens when I create a varchar 50 versus a car 50? And they're going to start talking about tuples, and you're going to get lost. We need more guidance at the high level for people like me. So that's one thing that you're going to see. And then the other thing I've run into, and this one's all on me. This is not anyone else's problem. Um, I make a lot of bad assumptions. I was making some bad choices on what I was doing. And because I had knowledge in my head that just isn't the same in Postgres. And so that was causing me issues. Don't assume that what you know is going to be correct. It might be different. So there's always find those differences. All right. So learning resources. The first one I have linked here, and again, all these are links, but the first one I have linked here is the path to CitusCon. And Ryan and I just did hey, I'm learning Postgres for the first time. What resources do I need? Well, follow this link to that webinar, or sorry, not webinar. What do you call it? It's a radio thing. Podcast. Thank you. It's to the podcast, and that's got a whole slew of learning resources. The next link I have here is to postgres.org. Is it academic and scientific? Yes, and that may cause you some struggle. Maybe not. Maybe you're smarter than I am, but well. However, it is the fantastic resource, so I recommend it. Next up is Planet Postgres. This is a blog aggregator. And so we get to see a lot of blogs, and we get to see who out there is promoting Postgres, who's doing interesting stuff, who's giving us the high level explanations that we need. That's where you go to get some of that stuff. Next up is Meetup and User Groups. And this one, again, goes back to postgres.org. There are some fantastic meetups and user groups out there. I've been to a few of them. I love them. They're a great resource. And then finally, I've got my articles, Learning PostgreSQL with Grant. This links up to the first one, and there are 12 or 14, and lots more coming. We're not stopping this until I feel like I've learned enough of Postgres to talk intelligently and not like an idiot. Anyway, there's a lot more going on there, so please do check that out. Now, Summit 2023 is coming up, and if you're looking for opportunities to learn, and specifically if you're looking for opportunities to learn Postgres, you can go to Summit, which is the largest data platform conference on the planet, probably the biggest data conference on the planet, not counting some of the analysis conferences, Oracle. Anyway, it's huge. And the early bird pricing is ending in a couple of days. And so you may want to try to get in on that. But here's the fun thing. There's a whole bunch of pathway content for learning Postgres. From install the first query, think like a Postgres, flexible indexing, Postgres at scale, and practical memory tuning for Postgres. And there are more sessions as well. These are just some of them. But that's cool stuff. So there's another resource for you if you want to get together with 5,000 of your closest friends and spend some time learning data. So with that, I am not quite over my time, but I am close to out of time. Here's my contact information again, just in case. If you want to get in touch with me after today, here it is. Please do use it. I answer questions. I do my best to help out. Other than that, with the minute that we have left, are there any other questions that anyone hasn't asked? No more questions? Okay, well, without any more questions, I'm going to go ahead and say thank you so much for attending. Hope this was useful to you. I'm really enjoying my own learning experience. Postgres, it's exciting technology. There's a lot going on there. Frustrating too. There's aspects of it that make me crazy. Wait until you get to the write ahead log. Wait until you get to the vacuum. But there's stuff in there that'll make you nuts, but there's also a lot of exciting things, and it's been a lot of fun. So I hope you enjoy your experience picking it up, and I hope today was at least a little bit helpful in giving you some highlights on learning PostgreSQL.